Hi all, welcome to GradStats 2024 Lab 2 in R and RStudio for descriptives and visualizations. So descriptives and visuals are for communicating about our data and summarizing the whole of the sample or the constructs of interest so that we can communicate the results to our reader, our listener, our colleagues, whomever we're communicating with. So for this lab, we're going to summarize categorical and continuous variables and create graphics to communicate those results. We will also evaluate an assumption of the data called Univariate Normality, which is typically required for the parametric techniques we'll be using later in the series. Materials you'll need for this lab include the survey dataset. It's called Survey 2024 Lab 2. And I have an example write-up for you, and you'll also need the Lab2 RScript. These are linked in the description. So let's get started. So opening up RStudio, the first thing we want to do is start our Lab2 script. Again, our goal is to communicate information about the data. To do this, we'll need to request summary information for categorical and continuous variables, and request graphics to help communicate about data information. We're also going to assess univariate normality for a couple of continuous variables. The materials you need, you'll need to install and load the following packages: Tidyverse, Haven, Janitor, and Psych. And make sure you put the SAV file in your working directory so that you have access to it. So we will load Tidyverse and Haven. And Haven is a package that makes importing SPSS data files easier. So that's the one I usually use that makes it easy. This code says assign to Lab2, which will be a new item in the environment, reading in the SAV, that's our function, of this file name. And that needs to be in my working directory for R to find it there. So running that, we have in our environment Lab2 with 439 observations and 130 variables. And when we fold this down, we see that there is a lot of stuff going on here. This is from bringing it in from SPSS, but it still got our ID wrong. It didn't recognize that sex is a factor, so we're going to have to fix things like that. But this is pretty cool because we can use our corrected script from Lab 1 to do these things, to fix the ID character and to set up our categorical variables. So all we need to do is get our Lab 1, whatever you finished and you know is correct, get that. And I'll copy over where I set up the ID. And then I also want where I did the sex variable. And then I want all of the others from marital through smoke. I'm just going to copy all of that and I'll clean it up in my script over here. So I can take out the placeholders that I don't need. There we go. But we still have some things to fix here, right? We did find out in the SAV more information about this major sources of stress, specifically items 8 and 9. 8 is stress about money or finances, and 9 was stress about like time conflict. So I can fix that on this one. And then the other item is that right now this code is looking for a lab 1. I don't have a lab 1 in the environment, so that's not going to work. But I can use find replace in the script here. I'm going to do Command F, and you can do Control F if you're on PC, and it opens up this entry area at the top. I want it to find all the lab 1s and change them to lab 2. Replace all of those, and it found 15 to replace. And now all of my code with the lab 1s is fixed. So that's cool. And I can run all of this in one hit. And now I have 136 variables. I'm going to go ahead and close out that area since I don't need it anymore. And that's good. Now we're all cleaned up. Now I am going to use another one of our deployer tools called Select to make a smaller subset of the data set so that I'm not working with all of these item level, like the OP 1 through 6, the MAST 1 through 7. I'm not working with all that anyway. I have the summary scale level variables that I want. So I'm going to use Select to make a smaller data set with just the ones I need. So what we're saying here is to create a new item in the environment called Lab 2.1 assigned by using the function select from the Lab 2 data set just these variables. Running that, that's better. Now I have, oops, looks like I missed a variable. I only have 17 here and I'm inspecting 18. Which one did I miss? It looks like smoke number, the continuous. There, now let's try it. There we go. Lab 2.1, 439 observations of 18 variables. Cool. So let's get a quick look at this using the summary function. Summary of Lab 2.1. And so we can see how many male and female. In a continuous variable, we can see the mean and the min and the max. But here on marital, this other is like it ran out of room, so it told us the first ones and then it just grouped all the others left into this other category, which isn't going to be good enough for us. We want to know exactly what other categories are left, not just lumped together, so we'll have to deal with that. It tells us how many missing responses, if there were some. And then again, that other, it's not enough detail there, but gave us some information. And on our continuous variables, we get the means, but not the SDs, not the standard deviation. But it's a good look and shows that we have all of our information here, so that's good. So let's keep working on this. So for categorical variables, we want a count, like how many, and percent of the whole for each level within the categorical variable. So if the categorical variable is sex, we want to know how many males, that's one level, and how many females, that's the other level. And we want to know what percent of the sample is male or female. For this, we're going to use the janitor package. and a function within janitor called table. So I want a quick little table of the sex factor. And what do we get here? We know that we have 185 males, and they represent 42.1% of the total. And it's in a decimal form, so you'll have to multiply by 100 to get it to look like a percent. So 42.1% and 57.9% of females. So we're going to write the other ones for all of these others. We can just copy that one and be able to write the others for our other categorical variables. And I'll go ahead and run all of these, and then we'll take a look at them in the console. So for marital, we have no missing values, and we know the percent of each level in this one categorical variable, because it's got 1, 2, 3, 4, 5, 6, 7, 8 levels in the categorical variable of marital status. In the do you have a child at home variable, there are 2 levels, yes and no. And we have 1 missing value. In other words, 1 respondent did not answer this question in the survey. So that's the difference between the percent and the valid percent columns. The percent column takes into account when there's missing items. In other words, this 1 missing still represented 0.2% of the whole sample. Whereas when you're looking at valid percent, it's looking at, out of those who answered the question, what is their percent of the whole. So 42.2% of those who answered this question said yes, they have a child at home. And 57.8% of those who answered this question said no, we don't have a child at home. And that, for our purpose in this lab, we're using the valid percent column when there is one. Sometimes you are interested in how many did not answer the question, because those can be interesting as well. But for what we're doing valid percent. And when there are no missing values, you won't even get that column because they would just be the same anyway. So we have all the categorical information we need for doing a summary of these variables in a write-up. So let's go back to our continuous variables. For continuous variables, we want a mean and a standard deviation, and we also want to go ahead and get skewness and kurtosis to evaluate normality. We're going to work through a process with Library Psych. I'm going to install that. And first we're going to help R identify which variables are continuous. Then we'll create an item in the environment with only the continuous variables in it. And then we'll request the summary of that new environment item that only has the continuous. Because R gets a little confused when we ask it to do something and it doesn't apply to all the variables in that environment object. So we want to make this little separate thing that only has the continuous variables in it. So what I'm saying is make a new item in the environment assigned by a selected application of, in the dataset, Lab 2.1, of those that are numeric, those variables that are numeric, in other words, continuous variables. And then once those are selected, right there, I want a item called data, which you can make it any name you want, assigned by, from this data set, anything in the data set that is part of that selected group. So now I have that new item over here in the environment. Now I want a summary of the mean, standard deviation, skew, and kurtosis, and all of those come in this package called, well, in the package psych, but the function called describe. And I'm going to put it in the environment with a name cont summary, assigned by describe function of the continuous data. So now it's over here. I can do a summary of it in the console. And if your console is like a little too skinny, it'll come out weird. Like if I did it with my console too skinny, it starts wrapping it around. But if I want it all on one block, all I have to do is stretch out that area and then run it. So it's all together, and we see the number, how many there were, the mean and the standard deviation. We even get the median and the trimmed mean, so that's cool. We got min and max, we got the skewness and the kurtosis. So skewness means that if something's not normally distributed, it might be leaning where all of the values are on the high side, and it's got this long tail on the left side. So if you have a hump and a long tail on the left side, so going towards the negative part of a number line, that would be a negative skew. And in any of these with a negative skewness number are going to be showing trends of a negative skew, whereas any with a positive skewness number are going to be showing their tail on the positive side. So all of the hump will be on the lower end, and the tail will be off to the positive side of a number line towards the right. So that's skewness. Kurtosis is telling us kind of how aligned the normal bell curve is. If it's too kind of spiky in the middle, you're going to see a positive kurtosis. Positive kurtosis is a very like high, fast curve, like really spiky in the middle. Whereas a negative kurtosis means it's kind of flat, and it's got just a flat distribution where you don't have those tails coming out in a swoop. It's more like a very chunky tails. So those are two ways we look at univariate normality. And univariate just means one variable at a time. For this one variable, it's got a negative skew and a kind of peaky kurtosis in the middle. And that tells us something about if it's violating univariate normality. But back to what we needed for describing our continuous variables, the mean and the SD, we have them for all of these variables. And this can be a little hard on the eyes, right here. You can also click on the continuous summary in your environment, and it'll put it up here in your script corner. And that's kind of easier to read through. It still gives us all the same numbers, but it's kind of prettier. And you can also sort. Like if you want to know which one has the highest kurtosis and the highest skew, we can sort it like that. So this one is smoke number. So how many cigarettes do you smoke is very positive skew and very positive kurtosis, so really spiked and not much of a tail. So things you can look at there. Let's see what's next on here. Okay, now we need some graphs to help us communicate. And the trick with R is really deciding what you need, what you want, and what you want it to look like. You need to have that in your head first when you are building your graphs. You've already done the ggplot orientation, so you're going to see a lot of that here. But let's go ahead and build a bar graph for sources of stress. Running this, pull this up so we can see it. Okay, it's coming together. How about we add some color to it? And we'll add some labels so that we can see what it is, or have it a little more ready for our paper, our write-up. All right, let's see what this does. Okay, almost there, but all the sources are kind of crammed together here. Let's see what we can do with that. I'm going to poke around for additional code. Sometimes I'll poke around on Google or in an AI generator, just trying to find something that will help me get it cleaned up a bit. So I'll take all of this, put it there. We're going to add all right, let's see if this will fly. Okay, that's better. So now I have where I can actually see what the categories, what the levels are within this one categorical variable of sources of stress. And that might be something I can use for the write-up. I can export this as an image, and whatever file name I give it, our graph Lab2 stress, it's going to save in my working directory. So bar graph Lab2 stress PNG, and I can from there put it into my paper. So the next thing we want to do is get a scatter plot. Let's take a look at a scatter plot between total perceived stress and age. Again, we're using just our ggplot skills. All right, that's what we need. We can add some clarification with titles, maybe color between the males and females, adding some more aesthetics. I'm going to copy this to get me going and then just add other things to it. Let's take a look at this. All right, that's better. I can work with that. And then one more graph, let's do a box plot. Let's have a box plot of sex and stress and see what we can do with that. Okay, let's see. That's cool. In a box plot, in the rectangle is 50% of the distribution, and the dark line in the middle is the median. And then the dots at the end indicate maybe some outliers going on. I'm going to see what this looks like flipped with our coordinate flip. Yeah, that might be better. And adding some titles. I didn't like something. Let's see what I did wrong. It didn't like the coordinate flip on this one, huh? Remove 6 rows. Let's look over very carefully. What do I have here? All right, I might need to reorganize this a little. Let me try putting the AES earlier, which will be x equals sex, y equals stress, and then add the geom box plot, and then add the labels, and maybe the only thing I was missing was a plus here. Let's see what that does. Okay. Now we got our labels, and it's flipped. Yeah, it probably was only missing that one plus and didn't have to reorganize there. Sometimes it's just working with it until you get it figured out there. Okay, so we have some graphs to work with. You can export whichever ones you want to use for your write-ups, and they're going to just go into your working directory area. So to finish looking at some univariate normality, our last task does this, and we do it by visually inspecting the histogram. Like we've already requested skewness and kurtosis and looked at how we can get an idea of how well the continuous variable is fitting a normal distribution with those two measurements, but we're also going to just look at the histogram. So let's start by working with a histogram for total perceived stress, and go ahead and add titles and color as you go. Let's see what this looks like. Oh yeah, that's pretty. We can do that. So we've got skewness and kurtosis, we have our histogram, and when you look at this, like we can see the peakies, and that's where that kurtosis value is coming in, and just barely you can see a little bit of positive skew where there's a less tail on this side compared to this side, but not that much. Overall, it's trying to be normal. So I can give it a little credit there. The other thing we use to evaluate univariate normality, or normality in general, is the normality test. And the one we have to work with here in R is, that's easy to work with, is Shapiro test. So we just call for the test on that variable. In our Shapiro-Wilks test, we see the estimate of Shapiro-Wilks and the p-value. And really the only thing we're interested in is the p-value. When we're looking at normality or assumption check tests, typically when you have a significant test, it means the assumption is violated, typically. So because we have a significant p-value here of less than 0.05, we would say that the Shapiro normality test indicated that total perceived stress is not normally distributed. And that's fine. I can say in the write-up that while it looks relatively normal in the histogram, Shapiro-Wilks test indicated a non-normal distribution or a violation of normality. Either way, you just let the reader know what you found. So to finish off this lab, go ahead and create a histogram and request the Shapiro-Wilks normality test for age variable and put them right in there. Be sure to save your script when you are finished with your lab, and here's also a handy resource for looking at normality tests in R. So the last thing we need to do is take a look at this write-up. In the write-up, this is set for APA. I'm missing the page number there, but you have level 1 heading, level 2 heading, and the content is we're letting the reader know about the data. This first paragraph is more demographic related, but basically when you have a categorical variable, you're letting the reader know about how many and the percent of the whole represented. When you have a continuous variable, you're letting the reader know about your mean and standard deviation for that continuous variable. And when you have some kind of graphic that you want to point the reader to, you let them know in the text where they're going to find that figure or table or whatever you're putting out there for better clarification of what you're trying to say. So this first paragraph is very much demographically related. The second paragraph is focusing on the constructs of interest, which were mostly about stress or personal characteristics. And again, it included some categorical variables and it included continuous variables. Then in this last paragraph, we tell the reader a little bit about what we're moving towards as far as the specific focus. I put, while perceived stress and age were not related, that's going to be our figure 4. There seem to be differences in perceived stress depending on one's gender. That's the box plot in figure 5. And as you're checking assumptions, let your reader know what type of assumption you were checking and how you evaluated it, like a visual inspection of the histogram or the Shapiro-Wilks test. And again, you're able to say what you think. You're the one inspecting the histogram. What do you think? And your feel for what you feel comfortable with saying is normally distributed or not is going to get more developed as you keep looking at histograms. So just keep looking at them and see how you go. When you do your figures, I'm having you put them in the end, like in an appendix. You always want your figure number, the title, and then the actual image. And the red areas are things that are wrong APA-wise. Like this should be capitalized, and these words should be in the same font as what's used in the paper. Because APA 7 gives us more flexibility on what font type we want to use, but you do have to be consistent throughout the paper. Each figure goes on its own page, and this one I did a little more editing and added both the count and the percentage for each of these categories or each of these levels of the categorical variable. And the red block here is because of consistency. In this figure, all of these levels have uppercase labels that are tilted down, right? But in my very next figure, I have lowercase labels that are tilted up. So neither of those is wrong, but you want to be consistent. I also found that it was almost easier to just not include a main title here and you put my title in Word itself, because I was better able to control the font type and the italics and the spacing and the location of it when I just went ahead and did my main title in Word instead of trying to put it in a graph. There's our scatter plot and our box plot. So check it out, and that is it for what we were doing in R. So we got a lot done here. This was all about getting the information we need from the data set about the variables, the categorical and continuous variables, to be able to communicate to your reader or your listener or your client, whomever, the nature of what you found in the data. So we did summaries of continuous and categorical variables and worked on some graphs, trying to get those graphs more easily from the analysis system to the MS Word. And we also checked out the normality, the univariate normality of a few variables. So good job, and I'll see you in the next lab.